Welcome to OMG Streams. I am Pam. You can find me on the internet at Pamasaur and my also somewhat dinosaur-themed website, thewebofwar.com. And so the thesis today that we're going to talk about is that streams are the most awesome data structure that you don't know enough about. So the goal today is that you are going to leave here as excited about streams data structure as I am. So step one, streams. So I'm going to start with some history. So I wanted to find out, when I became interested in the streams data structure, where the first instance of what the streams data structure looks like was. And as far as I could tell, it seems to be Unix. And so, wrong window. Hold, please. Excellent. So all glory to the pipe operator. So if you do something like this in Unix, so if you open your terminal, then cat lets you send the value from bestanimals.txt into the grep-i command. So the output from the first command is piped to the second command, is how you would say that. And so that looks like, just, because we can. So cat bestanimals, so that's that command by itself. And then if we had the pipe operator, called a pipe because it looks like a stick, but also you can think of it because data is flowing through it. And so we grep, so globally search, case insensitive for cats, because cats run the internet. And so we can, so if you've opened the terminal, you've been using streams, and that's actually where the first instance that I can find started, without even probably knowing that that's a streams data structure. So what are streams? So streams are an abstract data structure. That means that when you see a stream, like in Unix, it won't necessarily be called a stream. So it's abstract. So you can have multiple flavors of them. You might see them come in different forms, but ultimately they're still streams. So a real-world demo, I'm going to have my buddy Joe come up here, where we have a real-life experiment to demonstrate how streams work. But we're going to take water, and it needs to go from this first cup through the second cup and into the third cup, because reasons. So this is the task that we, on the assembly line, have to do. So here's one way to do it. All right, now with some highly specialized modifications to the second cup, we can make it more like a streams data structure. So let's swap these. So this is now cup one. All right, cool. All right, so now we're going to do this operation with streams. Are you ready? Yeah. All right. Yeah. All right, thank you, Joe, that you can keep that. You're welcome.
Thank you.
So the streams data structure is basically, it lets us flow through rather than having to make stops at every stage. And that ends up being really powerful. So I'm going to bring up SICP because this is kind of a canonical text. So SICP is Structure Interpretation of Computer Programs. If you have a computer science degree, you might have read it. If you have a computer science degree and you have not read it, you probably feel guilty about it. So it's a canonical text in computer science. And what it defines as streams are their delayed list. Well, what does that exactly mean? So a delayed list means that you can treat them like a list structure, but you don't have to have all the values at once. That's really tricky and really, really cool. So why would we want streams? Why we want this delayed list structure? Well, you can't or don't want to hold everything in memory, and bandwidth is expensive. So as we progress in computing, the facts change constantly. Some facts that are still true is we don't want to waste memory, and bandwidth continues to be expensive. It's not, it's not free. So we want to use streams to limit the use of those resources. So streams, and why you should be extra excited about them. So streams, being a delayed list structure, let you represent possibly infinite data. Infinite data, making you a wizard because you can represent infinity in data, which is really, really fascinating and really, really cool. So what are some things that don't have an end? You said infinity, that doesn't actually exist. Wrong. Some things that don't have an end, just a few examples, natural numbers, You can always get a new natural number by adding 1 to any natural number that you have. Weather, natural phenomena for a lot of UI people, keystrokes, events in the browser. You don't know when they end. Large data sets, your heartbeat, these have stars because they definitely have an end, you just don't know when it is. So you operate under the assumption that you don't have to care when the end is, and that's what streams let you do. They let you not have to care about when it ends. So why I brought it as ICP is partially so I could bring this up, is that stream processing lets us model systems that have state without ever using assignment or mutable data. That is really awesome, so let's look at it again. So awesome. So stream processing lets you model systems with state, but you don't have to incur the cost of assignment or mutable data. So you can move faster because you aren't storing things in memory and you aren't mutating data, which is something that we're talking about a lot today, these days. So really, really cool, and you should be really excited about streams, especially how they're able to represent how we move through the world nowadays. We move through large data sets, we move through real-time data, we move through things where we don't know when they end. And streams are the data structure that let us do that. So streams abstract data structure, that means it can come in multiple flavors. In general, it actually kind of splits into 2 standard flavors. So there's push streams and pull streams. So push streams are like the fire hose. So a push stream is you can think of it like the fire hose, like if you you're at the end of the fire hose and you just open it up, and then it's just pushing water out. And so how you can deal with that in computing, there will, it has its positives and has its negatives. So you think you're using a push stream when you see things like callbacks. So there's someone standing at the end of the hallway getting a fire hose thrown at them. They're doing something about it when they get the water thrown at them, I don't know. Non-blocking, so once the stream is open, it doesn't stop flowing. It just goes, so that's a push stream. And the downside, because there's cost to any structure, is that possible overload. So if you stood, 10 feet in front of a fire hose, that probably wouldn't go so well. In the same way, if you are a consumer, so in stream processing, we talk about producers and consumers or sources and subscribers, but they all kind of mean similar things. So if you have a producer and the consumer can be overloaded by a push stream from the producer, then that's a problem. So you have to use push streams in an environment where you're protecting against that. So the other flavor is pull streams. So pull streams, rather than having the data thrown at you, just, I can handle whatever data you throw at me, pull streams are more like a lake, like a data lake, a lake of calm data. And when you want data, you have to, get your bucket that holds data and walk to the lake, go get some data, and walk back. And while you are walking to the lake, you cannot do anything else. So in computing, that means that we tend to see this in the form of iterators. So walking to the lake and back, that's an iterator. It's also blocking. When you're walking to the lake and back, you can't do anything else. So you also want to, the cost you incur of that is the timeout. So you also want to never, ever block forever. One of my, should be on a t-shirt, that when you have pull streams, you don't want to block, you don't want to send someone from, from the village to the lake and then, be like, okay, well, I guess they'll come back, and then like 10 days later, you still haven't gotten any water. Don't do that. So similarly with pull streams. All right, so what do streams as the data structure look like in JavaScript? So abstract data structure, lots of different instances of streams-like structures. So node streams, conveniently named, they are push streams. So node streams, this is the classic example from Substack, who has a ton of awesome stream examples. So here's a very simple server that reads a file and then sends it to a response. Here's the important bit. So what it's actually doing is the file system reads the file into memory, and then it sends the response out, the data out to the response. So that's one way to do it. Just like pouring the water into the cup and into the other cup is one way to do it. So storing things in memory. There's another way to do it. So great thing about node streams, I really appreciate that it uses the word stream, number one. And two, it also uses the word pipe, just like we saw in Unix, our good old buddy Unix. And so the important bit is that the file system, we create a readable stream, and then from the stream, we pipe that to the response. So we take the output from the first thing that was happening and pipe it to the other thing that we want to happen. So we're piping rather than using memory. Node streams are awesome. They're great. Generators. Generators are a newer feature. They're in ES 2015. They are reusable and pausable functions, or are they pull streams? Indeed, I would say that because the way you operate on a generator is that you ask for more when you want more, also known as pull streams. So you know it's a generator when you see these kinds of indicators that this might be a generator. So function star and a yield. If you see those in a business, that's going to be a generator. So here's a very simple generator. It's a reusable and pausable function, so this does not do anything. However, if you create an instance of a something, so s equals to something, s.next, next being that keyword that calls to the next yield through the instance of the generator, then it's actually doing something. So I have some simple demos to show what generators look like. So some fun with generators. All right, we want to open up the console. All right, that looks good. Actually, I'm going to tack it to the right. All right, so we're going to generate. So generator done, false, and we have something over here. All right. Something else? Something else entirely. Okay, so that's and then now our generator's done. And if we continue to click, it's always done. So our instance of the generator is always finished. And so if we look at what that looks like in the simple generator, so our simple generator, we see that function star and that yield, those symptoms that we have a generator going on. And so in the first time we call it, when we call next, we run up to the first this. The next time we run up to that next this. And there's no more yields, but the next time we call it, there's still code to be executed. So it executes the code in the remainder of the generator. It's a great place to put finally and things like that. So now that you've seen the code, let's just look at it again just to, see it, how it works, and then see it do the thing. All right? So let's swap that out for a mildly less trivial one. So let's get rid of simple. Let's change it to string breaker. Let's see what string breaker does. All right. So John went to the store and said, hey there, to the clerk. So what does string breaker do? String breaker, so aptly named, because it is a reusable and pausable function that breaks a string into parts, into words, anything separated by spaces, except for the case where things are enclosed in quotes. So you accumulate until you hit a space, unless you're in quotes, and then you wait for another space. And so that's what this generator is doing. You can feed it different strings to have it do that behavior. So when we're clicking the button, it's sending that value of next into our paragraph. So now that we've seen it, we're actually going to change that behavior a little bit. And just uncomment some things. So what we're doing here is we're changing from going through an instance of our string breaker to using an iterator, which makes sense because remember, pull streams, often we use iterators. So we use another ES6 feature, ES 2015 feature for of, which lets us walk through the values of a generator. So we can actually create our instance of our generator right there. And assuming that I uncommented correctly, yep. So John went to the store and said, hey there, to the clerk. So that lets us walk through the generator with an iterator. So pretty neat. And so that's simple fun with generators. There's definitely more interesting things you can do with them, but hopefully that gives you a sense of some of the simple abilities. So can you use you probably want a transpiler like Babel to polyfill that. The example in there is running native in the browser, so up to you, but pretty interesting. All right, so that's some things that exist now, but what about what's coming next? This is the JavaScript conference, and we always talk about the things that we don't have yet. So I'm going to talk about libraries and emerging standards. So some libraries that you can use to work with streams, so not necessarily native capabilities, but let you model data in stream-like structures. So you have Bacon, Highland, and RxJS, so reactive extensions for JavaScript. So Bacon is a library. I've removed all the scary parts, and if you didn't get that joke, it's because it says functional reactive programming. But it's the underscore of an event. So if you're familiar with operations from underscore, then it gives you those operations on events. So it gives you let's back up, it gives you list operations on events, also which are streams. So events or streams gives you list operations on those. Highland is another library that you could use for this similar kind of task. It has a stream constructor, emphasis added, because I like when the words map to our mental models, that's nice. So you can put in many different kinds of values to get a common interface. So you don't have to just use one thing, you can use arrays, generators, readable streams, and they'll all, if you use the Highland constructor, it'll give you access to all those list-like operations, so map, filter, all those kinds of goodness. So RxJS, I call RxJS, I'm a fan, the reactive programming library for JavaScript. It is called Reactive Extensions for JavaScript. There is a new flavor coming out soon. So this is interesting to pay attention to because we have a current flavor and then the next flavor, which is they're under different repositories, and it's actually tracking against an upcoming standard that I'll mention, the observable standard. And this is also being used in Angular 2. So when Angular 2 comes out, you'll have access to these kinds of reactive tooling so that you can get streams of data and do list-like operations on them, which is really awesome. That's essentially what reactive programming is. So some recommended, so use the reactive programming words here. I know they're somewhat scary, but Stoltz has a really awesome long read, and also it's now in videos on Egghead for Intro to RX, really great resource. So some emerging standards. So there is a browser stream standard. So it's not implemented anywhere, but there's a standard that is being written out that brings things like node streams natively into the browser. As far as I could tell, the node streams people are involved, but they don't want to bring the exact same thing. They want to do what makes the most sense for the browser. Interesting, but we don't have anything to show for it yet. That's okay, because the interesting thing about this, the fact that the browser stream standard is being worked on is the fetch API. So how many of you have used the fetch API? I'm guessing a good number. Okay, yeah. So it's a really good thing to check out. It's basically the API that will let you stop having to include jQuery because you didn't feel like writing an XML HTTP request. So fetch simplifies that interface so much. You just say fetch some data, and then you get that kind of nice syntax going. So what's really cool about the fetch spec, though, is that eventually, instead of returning a promise-like object, which is when you get one value, it should return a stream-like object. So hopefully those browser streams. And what's really cool about that is it means that we're going to be able to do that kind of thing. So instead of promises where we have to stop at every station, like each cup, the water has to stop in each cup, and then only when you finish can you move on to the next stage. Instead of that, we can start passing data through. And the implications that has for speed and performance is really big. That's going to be a really big deal, and it's really exciting. Object.observe, you could consider a stream-like interface. So Object.observe, proposal for ES7, but there's been a good number of talks and articles about it up here to now. So you observe an object in the browser, and you watch for changes or mutations as you like, and do something with them. And the one I'm really excited about, the observable type. So Object.observe lets you watch stuff on the page. The observable type lets you watch pretty much anything. So you can watch events, you can watch arrays, you can watch generators, kind of like, it sounds like the Highland constructor, right? But it would be a native type that gives you a place to put the data source that you can then subscribe to. So there's a proposal for ES7, and the RxJS next, the next version of RxJS, that's what this is tracking against. So if you use RxJS with RxJS, which is currently an alpha, RxJS 5, I could say, so which is an alpha, it's tracking against this type. So that's the plan. So that gives you access to using this sort of thing now. So I have some small projects using some of these tools. The first being last week blogs. These are examples so you can see oh, okay, so nice libraries, but what it looks like when you actually use them. So last week blog, so I'll refresh this. So last week blog, it'll take a minute because it's probably gone to sleep. But so you can see how that rendered to the page, not all at once, but kind of cascaded, because it's rendering to the page before it has all the data. So what's actually happening in last week's blog is I'm getting, there's a setup where I have friends, and my friends don't blog enough, so I had to include the New York Times to get enough posts so you could see the visual. But in order to filter my friends' RSS feeds for things that have been posted in the last week. So that was the idea. So I get some RSS data, I pipe it to something to understand RSS data, and then I use Highland here to filter and map in order to send that response back to the browser. So I could operate on those, because it's really, I turn them into streams of data. So rather than saving them all and then letting the server crunch away, I'm sending the data as I have it ready. All right, so another one. So the space-time app uses the Fetch API. Fetch API doesn't have streams yet, sad face. But it also uses, I also updated it to use Gulp, which uses streams. So if you use Gulp, you've seen that you define a source and then you pipe it to different operations. So that's one of the reasons why Gulp is so fast, is that it's using stream objects. So space-time app is a visualization that fetches star data and lets you drive your DeLorean around and see how the stars move over time. So because the stars look different than now, so they move over time, I think it's correct, plus or minus, like either 10 or 100,000 years. At which point relativity becomes an issue. But it's pretty fun. The Fetch API is really that simple. It's fetch a stupid number of stars and then do a bunch of stuff with them and render them in 3JS in a 3D space. So another one, Millennial Snake People, popular Chrome extension. Also, there's Firefox add-on. I maintain that one. Also in Safari. Uses object.observe to appropriately update instances of the word millennial with snake people, such as in New York Times, snake people found lazy. Or my personal favorite, millennial children is changed to snakelets. So, really, really important stuff happening. But what it's doing is it's looking at the body of the document and watching for changes, which is streams. So it's dealing with callbacks. So it's a push stream, because just as data comes back from the observer, we deal with it with changing things to snake people. So really, really important stuff there. All right, now observable. So using RxJS. So this is just kind of fun. It's a silly art. So I'm observing where your mouse is going, and then you can click to place shapes. So I'm actually operating on your click stream and saying and partitioning the click stream, whether it's a single click or a double click or a multi-click, to place different shapes. So you can play with it, place different shapes. Just kind of fun. And the code for that looks like this. So we take our click stream, we buffer to debounce to figure out whether it's one click, and then we partition into two. Unfortunately, since I didn't include any polyfills, I couldn't do the beautiful array syntax where you do, thing, comma, thing equals the output of the array. But yeah, so I had to use actual array indexing, like the past. But yeah, pretty fun. All right, some interesting links. So node streams, conveniently there's a website called nodestreams.com. So there you go. Already have somewhere to go. And I did mention Substack, so the Stream Handbook, Streams Adventure out of Node School, great resources. Generators, Getify, Kyle has the You Don't Know JS book is all free on GitHub. You can also buy it with your money, which is also great. But there's a really nice generator section. And Axel has an awesome generators in depth. He always had really good resources for the new language standards, so definitely check those out. Reactive programming libraries, Bacon, Highland, Rx, and RxJS Next. Remember, they are two different repositories. So, and for what it's worth, the demo I showed was using the alpha version, but they should be compatible eventually. So, other cool reactive things, the reactive marbles. Just wanted to show those super quickly. So, as those interactive diagrams, if you're thinking, okay, well, list operations on streams of data, well, that's kind of a big, conceptual leap. The RX marbles let you look at what some different things look like. So what happens when I merge two streams? It gives you, so we call them marble diagrams. So these are marbles, and you can move the marbles around and see what the output of the list operation would be. All right, and so I include those links because the slides are all online, psla.github.io/OMG streams. Thank you so much. Find me on Twitter at Pamasaur, chat with me in the hallway, Webivore, Turing Incomplete. So Turing.cool is the podcast. All right, thanks.